Welcome to qnawire.
Okay, so in order to design an electric hair dryer, we need to design the electric hair dryer's diameter first. And we know we are using the hair dryer under regular conditions, which means that the temperature is room temperature, and the pressure is usually constant, which is about 1 atmosphere. So now we can set out such energy balance equation, which is W dot equal to M dot Cp times T2 minus T1. W dot here is the power inputs, M dot is the mass flow rates of the air, Cp is the specific heat for the air at a constant pressure, and the T2 is the final temperature, T1 is the initial temperature. So we know the mass flow rate can be expressed as a density of air times the area, and then times the velocity, which is P1 over RT1 times AV. P1 here is the inlet pressure, and we know pressure is constant, so the P1 here is just simply equal to 1 atmosphere. And R here is the gas constant for air, and T1 is the initial temperature. And if we plug and get back to the equation, we have W dot is equal to P1 over RT1 times AV, and then times Cp, and then times T2 minus T1. So we know the area can be expressed as pi times d over 2 to the power 2, and d here is the diameter we're looking for to determine. So if we do some arrangement here, we have such equation here. Eventually, you have d is equal to square root 4 pi t1 times w dot over p1 pi times v, and then times cp times t2 minus t1. So we know the gas constant for the air is 0.287 kilojoule per kilogram times Kelvin, and the initial temperature, which is the room temperature, is 23 degrees Celsius, which is equal to 300 Kelvin. And we know the power input is given as 1200 watts, which is 1.2 kilowatts. And the pressure at a regular condition is 1 atmosphere, which is 101.325 kilopascal. And we know it said should not exceed the velocity 3 meters per second. So therefore, let's say that the velocity in this case is 3 meters per second. And we know the specific heat for the air at a constant pressure is 1.005 kilojoule per kilogram times degrees Celsius, and the final temperature, or the maximum temperature, should be equal to 50 degrees Celsius. So now let's plug in back to the equation to determine the diameter. So the diameter is equal to square root 4 times 0.287 kilojoule per kilogram times Kelvin, and then times 300 Kelvin, and then times 1.2 kilowatts, and then over 101.325 kilopascal. Then multiply by pi, and times 3 meters per second times 1.005 kilojoule per kilogram times degrees Celsius, and then times the temperature change, which is 50 degrees Celsius, divided by 23 degrees Celsius. And this will give us the diameter of the hair dryer is about 0.126 meter. If we convert it to centimeter, it's about 12.6 centimeter. So therefore, we can design a hair dryer with a diameter 12.6 centimeter to satisfy with the requirement here. Okay, and these are the answers for this question.